An important, and yet unresolved question in natural resource management is how best to manage natural elements and their associated values to ensure human well-being. Specifically, there is a lack of measurement tools to assess the contribution of nature to people. The study presented one approach to overcome this global issue and show that the preferred state of any system element, in terms of realizing human values, is a function of element properties. Consequently, natural resource managers need to understand the nature of the relationships between element properties and values if they are to successfully manage for human well-being.
Two lines of evidences support the proposition that human values may be consistently linked to elements through element properties. Firstly, many scientists and resource managers have expounded the importance of properties to the management of natural resources in a more general sense. And a range of element properties such as size, rarity, and intactness have been routinely applied to quantify some specified or unspecified value when selecting conservation reserves. Secondly, numerous researches have directly linked specific properties of elements to particular values. For example, properties such as naturalness, accessibility, species richness, and vegetation structure have been variously used to score the importance of areas for recreational satisfaction and management. Since the goal is human well-being, natural resource managers need to understand and plan to shape system structure and composition accordingly. Such knowledge could also provide a powerful tool for informing debates and decision-making where there are conflicts over resource allocation.
To address this, they presented a method for linking the natural elements to human values in an applied planning and decision context. Specifically, they proposed that a. The state of any system element is described by its properties, such as size, rarity, species composition. B. These properties may be directly linked to human values, and c. Quantifying this link provides a means for estimating the well-being, or utility, that may be derived from any given element or set of elements. 2 case studies. Lake Bride catchment. About 1,400 square kilometers in area and is around 300 kilometers southeast of Perth, Australia. Bunting Marchagee catchment. About 1,810 square kilometers in area and around 130 kilometers northeast of Perth. For Lake Bride, 15 biotic elements were identified by technical experts and stakeholder representatives. In Bunting Marchagee, an initial list of biotic elements was identified by departmental project officers, which was then amended by an expert group, resulting in 34 elements. Each case study incorporated a one-day workshop with an expert group, followed by email discussions where required. In 2 case studies of applied planning, they demonstrated how to identify key element properties, quantify their relationships to priority human values, and combine this information to model the contribution of elements to human well-being. In one of the 2 case studies we also compared the modeling outputs with directly elicited stakeholder opinions regarding the importance of the elements for realizing the given priority values. The 2, largely congruent outputs provide additional support for the approach.
For this work, an expert was taken to be someone with skills, experience, education, training, and knowledge concerning the issues to be discussed and resolved. They identified and secured the participation of 8 experts for Lake Bride and 7 experts for Bunting Marchagee who met these criteria. The top 3 priority values for Bunting Marchagee in order of importance were ecosystem services, intrinsic/spiritual/philosophical contentment and future options. For Lake Bride, the values classification was developed with stakeholders and the importance ratings were determined by stakeholders. The top 3 values, in order of priority, from the stakeholder workshop were knowledge heritage, recreation and future options.
For Lake Bride, 6 element properties were identified as important. Total natural species richness, rarity, loss, 1/4 converse of intactness, size, visibility, and charisma. For Bunting Marchagee, the expert group also identified 6 properties. Total natural species richness, intactness, rarity, size, range limits and visibility. The results show that experts were able to identify the properties of elements such as size and species richness, and quantify property relationships with human values. Applying a set of novel analytical tools, this information was used to calculate the utility of elements in terms of supporting the realization of priority human values. Overall, the method used was successful in eliciting relationships between element properties and values that could be used to rank the importance of elements based on their relative utility. This provides an important means of prioritizing elements for management action. In one case study, we were able to directly elicit stakeholder estimates of the relationships among elements and values.
It is emphasized that this formal linking of element properties, utility, and values builds on the current use of properties in natural resource management. Turning to the modeling approach used. We chose to use a Type 1 fuzzy logic system because it allowed us to relate element properties to utility based on linguistic rules, while capturing uncertainty in the variables such as that arising from different levels of agreement, thus implicitly dealing with discord, in a context where multiple sources of information were available. The FLSs provided a sound basis to intuitively capture and model the complex relationships between multiple properties and values and provided a crucial level of transparency, interpretability and adaptability. Finally, it is acknowledged that a criticism of the above work will be that it is too subjective, and that the relationships between element properties and human values will vary depending on the interests and other characteristics of experts and stakeholders.
3 key conclusions emerge from the presented work. First, element property human value relationships can be quantified and used to better understand why elements are important and how they should be managed to maintain or improve their utility. Second, the approach facilitates communication and understanding among a diverse group of stakeholders and experts where views and motivations may differ. Third, the approach provides an important information platform from which to launch subsequent research, planning and management steps in the natural resource domain.